China makes more stuff than any other place on Earth. Phones, cars, buildings, clothes, solar panels, you name it, China builds it. But here is the part nobody talks about. All of that stuff eventually breaks. All of it gets old. And right now there are mountains of it piling up across the country. Instead of burying it, China is recycling those mountains using technologies that turn trash into something worth trillions of dollars. Machines that grind old car batteries into a gray powder that sells for more than gold dug straight from the ground. Machines that peel apart old solar panels to save tiny bits of silver you can barely see with the naked eye. Machines that crush entire buildings into gravel and lay it down as new roads the next morning. This is not about saving the planet. This is about building a completely new industry from waste. And the scale of what China has already built will change how you think about where the materials powering the future actually come from. Let us start with the strangest mine you will ever see. It is hiding inside a dead car battery. Stream 1. The mine hidden inside a battery. Think of an electric car battery as a locked box full of treasure. When the car stops working, most people just see a heavy black brick, something to get rid of. But inside that brick are metals that companies all over the world paid billions of dollars to dig out of the ground. Lithium, nickel, cobalt, manganese, copper, aluminum. The exact materials the entire electric vehicle industry depends on. Here is the part most people will never hear. Someone already did the hard work of digging these metals out of the earth, purifying them, and packing them neatly into one box. The box is shut tight, but the treasure is right there waiting. China starts unlocking it carefully. Every dead battery gets logged and checked. Any power left inside must be drained first. A charged battery that gets crushed can catch fire or explode. Once the battery is safe, workers check if it still has a second life. A battery too weak for driving might still be fine for storing solar power in a shed for a few more years. Giving batteries a second job is smart, but it only delays the inevitable. Every battery dies eventually. For the batteries that are truly done, something remarkable happens. Workers disassemble the pack into smaller pieces. Those pieces go into large industrial shredders. The machines rip through metal cases, plastic parts, and wires without stopping. What is left after shredding is a fine, dark powder called black mass. Think of black mass as the heart of the battery. All the valuable metals are locked inside this powder. Chemical processing can separate them and return them as pure battery materials. Those clean materials go straight back to factories making new batteries. A battery made from a battery. The circle is complete. The scale of what China has built around this process is almost impossible to believe. China handles roughly 70% or more of all battery recycling on the planet. For the shredding step, that number may be close to 80%. For the final chemical refining step, it is nearly 90%. China did not just build a battery recycling industry. China built the battery recycling industry for the entire world. But here is the detail that changes how this whole story should be understood, and most coverage never mentions it. In July 2025, China introduced a new national standard for black mass. 1 month later, black mass that met that standard was officially reclassified. It was no longer called solid waste. It became a product, something that can be bought and sold freely on the open market. While Europe was tightening rules around black mass and calling it hazardous material, China opened its doors and told the world, "Send it here." But there is a dirty secret hiding behind the impressive numbers. Licensed recyclers operating with proper safety equipment and regulatory compliance have been running at only 20 to 30% of what they can actually handle. The problem is not a shortage of dead batteries. It is that small, unlicensed workshops can afford to pay more for dead batteries because they spend nothing on safety or compliance. The licensed factories stand ready. The batteries go somewhere else. The system is real, it is enormous, and it is running half empty. But at least batteries hold enough financial value to justify the cost of the equipment. The next material is a completely different kind of problem. It was engineered specifically to resist being taken apart, and the wave of it heading toward recycling facilities is larger than most people realize. Stream 2. The impossible puzzle of old solar panels. Nobody likes to talk about what happens when a solar panel gets old. It is an awkward conversation because solar panels represent clean energy, a symbol of doing the right thing. But a panel that spent 30 years on a roof is not a clean energy hero anymore. It is 20 kilograms of glass, plastic, and metal fused together into one sheet that absolutely will not come apart. By weight, the panel is boring. About 2/3 glass, about 1/6 aluminum frame. Simple, heavy materials. But weight is the wrong way to look at it. Look at it by money, and everything changes. More than 60% of the financial value of a used solar panel sits in a thin layer of silver inside the silicon cells. You cannot even see it without dismantling the whole panel. It is like a painting where the frame is enormous and heavy, but the actual art, the part worth real money, is a tiny sliver you can barely find. In theory, recycling is straightforward. Pull off the aluminum frame, remove the cables and junction box, collect the glass, then break the fused layers apart to recover the silicon, copper, and silver underneath. In practice, you are fighting 30 years of extremely deliberate engineering. Every layer in that panel was sealed together for one specific reason: to keep out rain, hail, frost, and sun for decades without failing. The same engineering that made the panel tough enough to survive on a roof in all weather is exactly what makes it almost impossible to take apart. Getting to the silver means heating the panel to very high temperatures to break the adhesive bonds. Or it means using chemicals to dissolve the layers holding everything together. Both choices cost significant money and energy. Both create their own waste streams that need further handling. And the wave of panels heading toward this problem is arriving on a schedule you can predict almost exactly. China's solar industry estimates approximately 18 gigawatts of old panels will need processing by 2030, about 1.4 to 1.5 million tons of material. By 2040, the total could reach 253 gigawatts, roughly 20 million tons. The reason is simple. China installed an enormous number of solar panels in a very short window of time. They are all aging at roughly the same rate. It is like a whole neighborhood of houses built in the same year, all needing new roofs at the same time. Except the roof in this case is made of materials worth thousands of dollars per ton, if anyone can figure out how to get to them. Stream 3. The city rebuilt from its own ruins. Forget batteries and solar panels for a moment. By pure weight, construction and demolition waste is the biggest pile in China. It is not even close. When a building comes down, it leaves behind a messy combination of concrete chunks, steel bars, bricks, asphalt, glass, wood, drywall, insulation, and debris nobody can identify. Entire city blocks of material suddenly needing somewhere to go. Compared to battery chemistry or solar panel adhesive, the recycling process for construction waste is almost simple. Trucks bring rubble from demolition sites. Workers pull out anything large enough to reuse directly. Magnets grab the steel. Everything else, concrete, brick, stone, goes into crushers that smash hard material into smaller chunks. Screens sort the pieces by size. Air jets blow away light junk like wood splinters and plastic fragments. What is left is recycled aggregate, essentially gravel. It goes into road bases, fill dirt, and sometimes concrete blocks. Simple process, painful numbers. In 2020, China generated approximately 2.6 billion tons of construction and demolition waste. Of that enormous pile, only 312 million tons were recycled. That is 12%. The overall recovery rate sits below 40% by most measures. For comparison, the United States generates far less construction waste, but recovers approximately 75% of it. The city of Chongqing alone produced 167 million tons of construction waste in 2021, more than half of all its solid waste combined. Its recovery rate was under 30%. Here is the real reason, and this is the detail that most people never hear. The technology was never the problem. The money was. Crushed gravel sells for very little. Sending a truck to dump rubble in a landfill costs even less, especially when landfill fees stay low. For years in China they were. If dumping costs $5 and crushing costs $10, nobody volunteers to crush it. Quality is the other roadblock. Recycled gravel is only as good as what went into the crusher. Rubble from a clean, well-managed demolition site produces decent material. Rubble from a messy site is full of surprises. Drywall fragments, plastic pipes, wiring, and much of it is not safe for structural use. Engineers will not approve mixed recycled gravel for a tall building. So most of it ends up under roads where the only requirement is that it stays hard and in place. Construction waste is all about volume. The next stream is the exact opposite. It hides enormous value in pieces smaller than a grain of rice. Stream 4. The urban mine inside old electronics. Here is a fact that sounds completely made up, but is entirely real. A ton of rock from a gold mine might give you just a few grams of gold. A ton of old circuit boards can give you significantly more. The richest gold deposit near any major Chinese city is not buried underground. It is sitting in desk drawers, warehouse shelves, and boxes full of dead phones that nobody has gotten around to throwing away yet. People call this urban mining. It is not a metaphor. It is a precise description of how much precious metal is packed into the electronics that surround modern life. Phones, laptops, circuit boards, televisions, washing machines, motors, servers, and cables. Inside all of it sits copper, aluminum, steel, gold, silver, palladium, and sometimes rare metals most people have never heard of. The recovery process is a careful assembly line. Workers sort and collect, pulling batteries and hazardous parts out immediately before anything goes wrong. Reusable components get set aside, then dismantling begins. Sometimes by hand for delicate parts, sometimes by machine for bulk processing. Magnets grab iron and steel. Eddy current separators use precisely tuned magnetic fields to flick non-ferrous metals like aluminum out of the stream. Optical scanners and density systems sort what remains. Finally, smelting or chemical processing extracts the pure metals, either melting everything in a furnace until metals separate from junk, or dissolving metals out of crushed circuit boards and recovering them from the liquid. Between 2024 and 2025, approximately 53 million used appliances and phones entered standardized dismantling channels in China, growing at 12% per year. One licensed facility in Fujian handles more than 2,000 dead appliances every single day. A refrigerator goes in one side and comes out as separate streams of plastic, metal, and foam. A washing machine takes a completely different path. The heavy concrete counterweights come out first, then the motor, then the drum, then the control panel. Electronics recycling works financially in a way that most other waste streams do not. Gold and silver are valuable enough to pay for sophisticated factories. When one circuit board contains more gold per ton than a ton of ore from a mine, you can justify the equipment to extract it. The economics align. The industry grows. But now we come to a material where the economics are almost impossible to make work. Its valuable parts are cheap, dyed in dozens of colors, stitched together with 5 different fiber types, and almost completely impossible to separate back into anything useful. Stream 5. The shirt that refuses to die. Grab any piece of clothing from your closet and read the label. If it says 100% cotton or 100% polyester, you have a recyclable problem, but at least a solvable one. If it reads 60% cotton, 35% polyester, 5% elastane, plus a printed logo, water-resistant coating, metal zipper, plastic buttons, and chemical dye, you are holding something that almost no technology currently operating on Earth can turn back into a new shirt. That is the core problem of textile recycling in a single sentence. Purity is everything, and modern clothing is engineered on purpose to be impure. Every feature that makes a shirt comfortable, stretchy, resistant to shrinking, and capable of holding bright colors comes from mixing different fibers. And mixing different fibers is exactly what makes the shirt almost impossible to recycle into anything useful afterward. Chemical recycling offers the most promising path forward. Instead of shredding fabric into progressively weaker fibers, you break polyester down to its fundamental chemical building blocks and rebuild it from scratch. A company in Zhejiang province is already doing this at significant scale, producing recycled DMT, one of polyester's core chemical components, at 99.9% purity. Current capacity stands at 50,000 tons per year, with projections reaching 500,000 tons of regenerated fiber by 2030. The catch is that it only works cleanly on pure polyester. If the garment is a cotton-polyester blend, the cotton gets in the way of the chemical process. Separating natural fiber from synthetic fiber cheaply and reliably at industrial scale is still a genuine unsolved problem. The honest numbers tell the full story. In 2020, China generated approximately 22 million tons of textile waste and recycled about 20% of it. The government's most ambitious official target by 2030 is 30% recycling. Read that carefully. Even the plan itself acknowledges that 7 out of every 10 garments will never come back as fiber again. Stream 6, the power plant inside a trash bin. Food waste is the stream everyone forgets. And in China, it is not a small side issue. In Shanghai alone, wet food waste makes up approximately 60% of all household garbage. Think about that. More than half of what goes into a household bin is food scraps, cooking waste, and organic material. It is also the most destructive thing you can mix into the rest of your trash. It is heavy, it is soggy, and it ruins every dry recyclable it comes into contact with. Imagine dropping a wet sponge into a box of clean cardboard. The entire box becomes useless. Water in the bin also dramatically lowers the energy content of everything else you might want to burn for power later. Food waste does not just create its own problem. It actively breaks every other solution around it. Pull it out of the mix, though, and something remarkable happens. The technology is called anaerobic digestion. Organic waste goes into a sealed tank with no oxygen present. Bacteria inside the tank consume the food waste and release biogas, a mixture of mostly methane and carbon dioxide. That gas can be cleaned and burned to generate heat or electricity. It can also be processed further into vehicle fuel. The leftover material, called digestate, can potentially become fertilizer. The catch is that digestate is only as useful as what went into the digester. It can carry bacteria and heavy metals from contaminated food waste. It is not automatically safe to put on agricultural land, and Chinese cooking produces particularly salty food waste. Salty compost is not much use for growing plants. These practical complications are why processing capacity grew more slowly than the collection systems feeding it. Then came the law that changed everything. July 1, 2019. Shanghai passed mandatory household waste sorting, requiring every home in a city of 24 million people to sort garbage into 4 separate bins: food waste, recyclables, hazardous materials, and residual waste. Residents caught sorting incorrectly faced fines up to 200 yuan. Companies faced fines up to 50,000 yuan. At first, residents complained loudly. The topic exploded on social media, with people joking about being driven crazy by the rules. Inspectors standing at bins checking what people threw away became a running cultural moment. Then it worked. Sorted food waste jumped from approximately 4,000 tons per day to a steady 9,000 to 10,000 tons, more than doubling in a short period. The separated food waste arriving at processing plants reached 99.5% purity. That number matters more than any other in this whole story. A digester full of plastic bags is a broken digester. A digester full of food waste at 99.5% purity is a machine that works. Hazardous waste recovery went up by more than 10 times. Residual waste dropped by approximately 20%, and the dry trash that remained after the food waste was separated had nearly double the energy content of mixed waste, which made it dramatically more efficient to burn for electricity. The most powerful recycling tool Shanghai deployed was not a machine or a chemical process. It was a law that told 24 million people which bin to use. Stream 7, the giant ovens that swallow the rest. After reuse, sorting, recycling, and digestion, a significant pile of material remains. What happens to it is the most misunderstood part of this entire story, and most coverage gets it wrong. Burning trash is not recycling. It is important to be clear about that. It is waste treatment with energy recovery. It shrinks volume. It generates electricity and heat. You can even recover some metals from the ash left behind. Magnets pulling iron and steel from bottom ash. Other systems capturing aluminum and copper. But a plastic bottle that goes into an incinerator will never be a bottle again. It becomes heat, electricity, and ash. By end of 2024, China had 1,129 waste-to-energy plants running. Their combined generating capacity reached 27.38 gigawatts. They produced approximately 145.3 billion kilowatt-hours of electricity. According to research published in Nature Communications, these plants supplied up to 7% of China's residential electricity needs in 2023. By that same year, more than 78% of urban trash in China was going to incinerators. Sanitary landfills had shrunk to approximately 13% of disposal. The image most people still carry of Chinese cities ringed by giant trash dumps is simply out of date. A modern waste-to-energy plant is a carefully controlled industrial facility. Trash burns at very high temperatures to ensure complete combustion. The heat boils water, making steam that drives turbines to generate electricity. Before exhaust gases leave the facility, they pass through multiple filter layers. Giant fabric bags catching particles. Chemical sprays neutralizing acids, activated carbon-absorbing toxic compounds. The result is exhaust that is predominantly water vapor and carbon dioxide, far cleaner than an open fire or an older-style incinerator. And here is the connection that ties the entire system together. The sorting revolution and the burning system directly reinforce each other. When wet food waste is removed from the trash stream, everything left is dry. Dry trash burns hotter. It burns cleaner. It generates more electricity per ton. Shanghai's mandatory waste separation did not just help the digesters, it made the incinerators dramatically more efficient simultaneously. Sorting makes burning better. Burning handles what sorting cannot recycle. Two systems that seem unrelated turned out to be the same system operating in sequence. Now step back and look at everything together. Dead car batteries becoming new batteries. Solar panels being peeled apart for their hidden silver, buildings crushed into road gravel, circuit boards mined for gold that outperforms ore from the ground, shirts being chemically broken down and rebuilt as new fiber, food scraps generating electricity, and the remaining waste burned in a network of 1,129 facilities, generating power for millions of homes. The country that made more goods than anyone else on Earth is now building the systems to consume those goods when their time is up. The money remains genuinely difficult for mixed plastics, for mixed fiber clothing, for contaminated construction rubble. These problems are not solved, they are real. But the direction is unmistakably clear. And China is further along this road than most of the world has stopped to notice. The question worth sitting with is this. If you were in charge of building a recycling system for an entire country, which of these materials would be hardest to get right? Batteries, solar panels, buildings, or old clothes? Drop your answer in the comments. And if this video showed you something about the future of materials that most coverage completely skips, hit like and subscribe. Because the recycling race is already running, and the country that wins it will control the raw materials that power everything built next.